Thanks, James. Continuing the theme of hybrid cloud environments, we've seen Charmed operators make it easier to deploy notoriously complicated infrastructure, such as OpenStack, for the last decade. Now we're looking at a world where enterprises are mixing Kubernetes and OpenStack environments. How are they doing it? And how are they automating their applications along the way? I'd like to introduce Billy Olsen and James Page. Gentlemen, the stage is yours.
All right. Thanks, David. Yeah, so it's nice to be with everyone today. My name is Billy Olsen, and with me is James Page, and we're going to be talking about evolving Charmed OpenStack into a bright new future. So we'll take a moment, introduce ourselves, because many of you may or may not know us. I'll let James go ahead and start. James, why don't you tell us a little bit about who you are?
Thanks, Billy. So I'm James Page. I'm a principal engineer at Canonical. Amongst other things, I'm also a Ubuntu and Debian developer. And I've worked on OpenStack and supporting technologies for the last decade or so at Canonical as part of Ubuntu. I also have just run the London Marathon, and I keep bees.
Awesome. Yeah, that was great to actually see you kind of run the London Marathon. Of course, I wasn't there because I'm in Arizona and you're in the UK, but virtually I could actually see you and support you. So I'm Billy Olsen. I'm the engineering director here at Canonical, responsible for OpenStack and Ceph engineering. Unlike James, I don't run. James does a good enough job of running for both of us, thankfully. And I do hobby rockets and kind of fly things around and build things and kind of watch them explode, and that's kind of good fun. Hopefully it doesn't explode, but we'll see how it goes. But we're not here to talk to you about that today. We're here to kind of just give a little bit of introductions and kind of talk to you about a little bit of something different. James, what are we here to talk to them about?
Wait 1 sec. Isn't this KubeCon? Why are we talking about OpenStack?
Wait, KubeCon? I thought we were here at the OpenStack, at the OpenStack Summit. No, okay, KubeCon. So KubeCon, well, what are we doing here?
It turns out that that OpenStack, like a lot of modern software stacks, is actually a big load of microservices. So, but if we just flip to the next slide, what we can see here is like the V1 service topology for OpenStack. It's actually quite an old picture now, and it's evolved and got much bigger over time. But what we can see is that OpenStack and specifically the control plane of an OpenStack cloud is actually a very complicated set of API services, web services, message buses, databases, data stores, that type of stuff, and a lot of relation and configuration that is required to put them together into a solution that forms OpenStack. And this is a common problem that we see in many big complicated software solutions that we have today. So OpenStack's one, Kubeflow maybe is another one. There's lots of different moving parts, lots of things that need to be plugged together. So what do we need in terms of how we can to deploy OpenStack? So Billy, can we move to the next slide, please? So back in the dawn of time when Linux distros were appearing, we really solved the problem of how to get a piece of software installed into an operating system quite elegantly. So for Debian and Ubuntu, this came in the form of a Debian package, and we can use apt to install that from the main Ubuntu repository. We run a single command, we get a running server providing some services. However, that kind of doesn't work for OpenStack. How do we sudo apt install OpenStack? It's a much more complicated solution. There's all those services we need to deal with, scale out. We need to configure them all. We need to talk to each other. There's a lot more than we can achieve with the primitives that Debian than we can achieve with the primitives that Debian and apt packaging, apt distribution give us for distribution. So we needed something a bit more complicated. So
I think evolved rather than complicated. Yeah, advanced. Yeah,
something that operates at a bit of a higher level. So what we've ended up with is due to deploy OpenStack. Now that encapsulates a huge amount of complexity and optionality and coordination, and it makes use a lot of what we call charmed operators. And charmed operators are the kind of nuggets of distilled DevOps knowledge about how each part of OpenStack is deployed and then put together to form the solution that is OpenStack and a private cloud at the end of the day. So let's just have a little bit of a look back in time and see where we've come from over what's actually more than a decade now. So way back in 2010, we had the first OpenStack release, OpenStack Austin. Small, relatively small community, lots of excitement, maybe 2 or 3 services. It was really, really simple. And then there's a few things that have happened over the last decade. About a year later, we wrote our first Charmed operators for OpenStack at Canonical. We realized that we were distributing OpenStack as part of Ubuntu every 6 months. We needed to test it as much as anybody else needed to actually deploy it to have and use a running private cloud. So we started writing Charmed operators to enable us to be able to test and deploy OpenStack as part of Ubuntu. Those first commits were in projects like Keystone and Nova and Glance and some of the very early projects that constituted OpenStack. Sort of 4 or 5 years later on from that point, Kubernetes 1.0 was released. So it's kind of like a significant milestone for the Kubernetes community and a bit of a different way of thinking on how to do deployment and operations for applications. 2021, moving forward to kind of last year, we had the launch of the ops framework for Charmed operators. That's an evolution of how we write charms and Charmed operators from how we've done it over the last 10 years to make it more Pythonic, more consumable, easier to understand for people writing operators. And then moving forward to today, we have Project Sunbeam. And Project Sunbeam, which we'll talk about in a little bit more detail, is our evolution of our OpenStack control plane to use Kubernetes and Charmed operators to aid with deployment.
You know what strikes me about this timeline, James? As I'm looking at it, like Austin release, 2010, right? And here we are on the OpenStack. We've just gone through this ad release. Like we're 26, we're the whole alphabet through, and we're about to wrap around again for the next one. So I think it says something that's pretty impressive.
When you think about it, isn't
Yeah,
it?
it's impressive to see that how these Charmed operators have held up through all those particular releases and shown actually kind of like through time and through evolution exactly how nice it is and how it fits together across a variety of things. I honestly don't know that we would have been able to deliver OpenStack with the quality that we have on Ubuntu without having this types of testing frameworks along the way and deployment frameworks. So
Sure.
I think it really stood up there. So okay, but we're here to talk about substrates as well and Juju and other things.
Absolutely. So Charmed operators are great because they allow us to kind of focus in on a specific service and how to deploy and configure it and to relate it to other services, which we'll dig into in a little bit more detail shortly. But they're kind of like the tip of the iceberg. There's a huge amount of engineering and wiring that needs to happen to get us to a point where we can even start thinking about deploying an OpenStack service. For the last 10 years, we've talked about machines predominantly when we're deploying OpenStack. So, a running operating system, potentially with a kernel and syslog and SSH running and all those different things. And Juju has been really good at allowing us to put Charmed operators down on machines. And it does that for us predominantly in 2 different ways. One using Ubuntu MAS, Metal as a Service, that allows us to address a data center of servers via an API for kind of provisioning and configuration purposes, and LexD for machine containers. So these are machine containers that have a full running operating system rather than just a single application within them. And that allows us to kind of like segment the physical machines that we've been given into mini machines that we can then put the Charmed operators down on to deploy the various parts of OpenStack. And Juju allows us to glue all of these things together so that we can have a very orchestrated and elegant deployment solution for OpenStack, which in the end gives us the solution that we have today for deployment of OpenStack. Could we flick to the next slide, please, Billy?
Yeah.
So with the OpenStack operators as we have them today, we're an upstream project in OpenStack and have been for a number of years now. We cover 70% probably of the OpenStack services. We have a lot of the supporting tech that's needed for deploying OpenStack as well. So the project owns operators for deployment of MySQL, RabbitMQ, Ceph, OVN, OVS, all the various different things that we need to, put not just OpenStack together, but a cloud together as a solution. So it's grown and it's evolved and it's done as well for the last 10 years. I'm going to hand you over to Billy now, and he's going to talk a little bit more about some of the strengths of operators and why they're a really compelling story for deployment and operation of applications.
Yeah, thanks, James. So I think one of the things that I talked about and kind of alluded to earlier is that, if we look at it, there's been 26 releases of OpenStack, right? Like A through Z. Like, can you believe it? It's been that many. Um, and here we are. We've been using Charmed operators for Canonical to deliver most of these things since 2011, 2012, that time frame. And so we go all the way back to like the Folsom release, the Grizzly release, those types of releases that were older. Sure, it was some time into it, but how do we actually continue to really grow the way we actually deliver software from Ubuntu? And Charmed operators were a nice ways of actually fitting in there. So one of the powerful things that it has enabled us to do and is to take a look at what is it really that a service has. So it kind of flips itself on its head on saying basically everything is as a service. So Keystone is your identity as a service. Your database, your MySQL is database as a service. And we think about these things in the cloud when you look at like AWS or Azure or different places like that. Everything is basically as a service that you're getting. And from a charmed operator perspective, I think that's one of the things that's really, really nice is you basically write your charm and then you have these nice relations in there so that you kind of treat everything as a service. So when you want your Keystone service and you want to bring that up, you can basically say, my Keystone requires a database service. And so then, well, I've got a MySQL service or MySQL service, however you want to pronounce it. I know there's that can be a little bit kitschy. Some people want it in certain ways. You have your MySQL service. It's going to provide a service. It's providing a database service, and ultimately your Keystone charm or your Keystone service doesn't really care about all of the details about how MySQL is set up. It really cares about what the connection parameters are and that it can get a database to it. And so that's essentially treating it as a service. And so in this particular example that we have where Keystone is working with the database, this is the nice thing about relations is Keystone says, I require a database. And your MySQL charm or your charmed operator says basically, here you go. I'm providing you a database. Here's the credentials and here's the database that you can actually access to access your database and set all that up. And that's actually been really powerful and at the heart of a lot of the different pieces of the solutions as we come around. Because once you get the relations, you don't have to worry about the configuration of like, this is my user, this is my databases I have, this is the IP address I need you to access it on. Those can change and be ephemeral over time and you don't worry too much about it. You essentially just need it to, the database will provide you these particular pieces of information and make sure that the Keystone charmed operator actually responds to what those particular values are. And once you get the relations right, it actually leads us into a nice thing to where we can start looking at modeling and focusing on what does the architecture of our solution actually look like? Do we have one monolithic database that's actually set up and stood up out there so that we have all of the individual services reaching out to MySQL and configuring it and pulling it in that particular way? Maybe it works in that for that particular example for a small, tiny little cloud where you don't have a lot of nodes to actually dedicate towards a database, or maybe you need something different as you grow, to where you have a different type of database situation here, where you've got one database that kind of is for Neutron and for your networking configuration, one database which is for your instances because you have a lot of instances in your cloud and you need to keep track of that. And then you have some services that don't require that many databases. And so you might be able to reduce that. And that's all just modeling. And I think the nice thing here is it's a very, very simple way. All the charms support this. The charmed operators, as you come in, they support it nicely just by having these relations of defining everything as a service. I want to treat this as a requires and provides, and having the actual different database services and other services. So Keystone could be in the database for all the other services here, but basically treating it as a way of a consistent provider of the service for each of the individual units. And I think that just makes it so nicely that you can actually plan for it from that perspective. And it's allowed us to evolve different things. It's allowed us to kind of like evaluate what our architecture is, adjust, make tweaks to our architecture. It allows us to kind of help users migrate to new architectures. So if you want a different database along the way, I mean, remember this, James? We actually had a switch of database along the way where we went from Percona cluster to a Galera-based MySQL cluster, right? And so making some of those particular changes are fairly simple. I mean, yes, you have the database backup and restore, but you keep those same relations in place. And so then you can basically do drop-in replacements of whatever particular application you're looking for to provide that. You're just looking for the service that's actually there. It's really powerful. But but we're also looking at evolving as we kind of go, and these relations have been nice in helping us actually do evolving without leaving any of our users behind. So there have been a variety of users who have bought into the overall solution that we have, and actually using a cloud based on OpenStack, and we don't want them to be stuck. This is a challenge that people run into, is they get locked into, say, a Stein release or a Queens release or something to that effect, and it's difficult to upgrade a cloud. And so as they go into upgrade a cloud, they don't want to be stuck at one particular place because they chose a specific vendor, or because they can't do the package upgrade. So we've been making sure that everyone can do upgrades with our software using our OpenStack solution from the get-go, and that's been really important. And these relations help us actually map that, and the Charmed operators help us map that, because now once you have the interactions, we can start looking at other solutions, like putting certain pieces on Kubernetes. So James, why don't you talk to us a little bit about the evolution and stuff?
Okay, thanks, Billy. So we kind of alluded to this a little bit in our timeline, but sort of last year, Juju grew support for deployment of Charmed operators onto Kubernetes. So moving to a application container-centric architecture rather than a machine-centric architecture. Now the machines have served us well for the last decade. However, it's hugely complicated. Every machine has one or more IP addresses. It needs securing, has to have SSH keys. There's lots of different things that make it harder to manage when we have lots and lots of machines. So due to growing support for Kubernetes was a kind of a reflection point for us as a project, and we started to think about how we might make use of this enabling technology within Juju to think about how we operated the control plane for our cloud in a different way going forward. But still making the most of all of the cool things that we love about Charmed operators, relations, upgrades, all the things that we've invested in and we've managed to drive good value out of in the last decade. We wanted to retain all of those things. So Juju and Charmed operators in Kubernetes felt like a good point to start maybe thinking about how we delivered OpenStack in a slightly different way. And hence, next slide, please. Project Sunbeam was born. So Sunbeam is the code name for our kind of mixed mode OpenStack, if you like. We're not going 100% on Kubernetes. We still feel that there's places where services benefit from being directly on the metal, and that Kubernetes, although it provides some primitives that can help us do that, doesn't add huge amounts of value in terms of what it can provide. So, but what we really want to do is leverage Kubernetes where it makes sense for us, where there's a lot of value that we can drive into either operational processes or other aspects of what we're doing in terms of development as well. So next slide, please, Billy. Let's have a look at what the architecture for Sunbeam looks like. Actually, I think I'll let you talk about this one, because I know this is one of your wonderful pictures. So
yeah, so I think one thing that's exciting about this is because we have that like real nice abstraction of the Charmed operator, right? Whether it's a machine operator or whether it's a sidecar operator that's running within Kubernetes. The nice thing is you get that consistent interface of working with Juju and the actual interfaces to manage the services, right? And so depending on where you're actually running them, your Charms might look a little bit differently. Your Charmed operators might look a little bit differently on the inside. But from an operator perspective, it feels the same in a lot of different things. And so one of the things that we do when we come in here and we take a look at what we want, how we want users to experience this, is we want to have our compute nodes down here. So these are the traditional bare metal servers that we have with Legacy containers that are running on top of them for some of the services. And some of the services may be running just bare on the machine itself. So in this particular example, we've got 3 different compute nodes. We've got the Nova Compute services that are running down there. This happens to be a hyper-converged architecture, so we're also running Ceph OSDs. We're running Cinder Volume. That's actually there if you want, because if you need access down to the actual like iSCSI or fiber channel accessors to be able to map different LUNs and volumes to the server, you need certain privilege escalations and things. And Juju allows us to actually map it in a variety of ways. And these Charmed operators allow us the flexibility of being able to run it inside a machine container or on the bare metal or even in the Kubernetes spaces. which is really powerful and really nice for us. And so what you're seeing here is you're seeing the control plane services, the ones that really make sense. They're basically a bunch of small web-based Python services that are the bread and butter of running in Kubernetes, all these nice web services. And so we're going to run those in the Kubernetes particular spaces. We're even going to run some MySQL in there, which will be good, exciting things. But one of the powerful things is, the semantics around Kubernetes and doing the recovery, and the whole idea of making sure that we keep services up and running. I want 3 units. I don't care where they're running. Just make sure I get 3 units and run it from that particular perspective. In this, we want users to kind of we envision that users are going to interact with it through a snap, which will then set up the Juju aspects and interacting with the different pieces, whether it's Kubernetes or whether it's machines. So some of that will be abstracted for the initial introductions to it, so you don't actually have the need to dive into it right away, and you can get that power when you need it. It's all driven there. And we envision this, and actually are working on making sure that this is working from the small type setup of where you're just going to go and do a snap install on each particular node, say on your desktop, on your friend's desktop. James, I'm going to add your desktop to my particular cloud just by a snap install over there. No, I don't think so. You're shaking your head no.
No, it's way too much latency across the Atlantic.
Oh, I think it'd be kind of fun. We could have another availability zone there. That's how it would be. But with the MAS here, we can actually grow it towards either on the local and doing it in a small snap type setup, or we can actually use the bare metal provisioning from leveraging MAS to basically deploy the enterprise grade servers. So that's kind of where we're thinking about and looking at from an architecture perspective. James, do you want to talk to us a little bit about some of the Charmed Kubernetes operators and why we find this more appealing? I mentioned a couple of things, but I think that you can probably highlight a little bit more for me.
Absolutely. Let's dig in on that topic a lot. When you look at our machine Charmed operators, they're actually individually all quite large code bases now. They have to deal with a lot of stuff in terms of configuring things like TLS termination, load balancing, clustering, whatever it might be. Really modeling scale in, scale out, upgrades, whatever it might be. So when we look at Kubernetes Charmed operators, we actually get a lot of stuff like that from Kubernetes itself. So there's a whole load of Kubernetes features that we can just directly leverage that we don't need to have modeled in the charms themselves. So things like load balancing and ingress to services completely handled by Kubernetes. Rolling upgrades being a kind of like the wish list feature for every operator over the last decade. How do I roll through my units, make sure each one's done and upgraded before I move on to the next, and if something doesn't work, stop. Right? These are kind of like nice operational primitives that we can leverage directly from Kubernetes. Health checks, very much links in with rolling upgrades and automated recovery. So if a pod goes bad, what do? We just throw it away and start a new one. So it's made us think about how we write an operator in a much more different way, and as a result, they've become much simpler, much cleaner code bases. So we're very much concerned about interacting with relations, right, and managing the application rather than managing all the different kind of non-application things that we need to worry on top of that. But I think one of the biggest bonuses of moving to Kubernetes Charmed operators is the repeatability of deployment. So when we look at a machine-oriented deployment, we're using Ubuntu, we're using a number of archives and Debian packages from those archives for deployment. If we deploy a machine now, we get today's archives. If we deploy a machine in 30 days' time, we get what's in the archives in 30 days' time. Now, those things should be compatible because we make a lot of effort into making sure that for a given series of Ubuntu and a given release of OpenStack, that there is compatibility between versions. But you're not getting exactly the same thing, and that can be super frustrating, and it can be hard to manage and debug when there's a minor issue because of some sort of incompatibility that's been introduced because of that difference. For Charmed operators, we actually version the containers along with the charms themselves. So when we deploy revision 1 of the Nova charm, we always get the OCI image of for Nova that matches that, and it's always the same OCI image. Right now, if we want to change that, we can bump those revisions and we can test it and we can deploy it. But revision 1 of the charm will always deploy with the same version of the OCI container. So I'm gonna hand you back now to Billy. He's going to talk a little bit about what we're doing with our application containers and how we're going to deliver those as part of Sunbeam.
Yeah, so I think that one of the really interesting things here is that, if we look out, as in many open source communities and stuff, there's already someone who's interested in doing some of the parts that you're actually already focused on in different ways. Or maybe you're the first one actually getting there. But in this particular case, in the upstream community for OpenStack, there is the Kolla community, which has been building OCI images for a while now for various OpenStack releases. Because, we certainly aren't the first people going to run in container-based OpenStack, and I'm sure we won't be the last. However, we are making sure to take our time and actually getting there with the right thought process and right diligence around different pieces as we go, and make a very specific, tasteful choice in going after which particular pieces go where. And we want to stand on the shoulders of giants, essentially, and acknowledge the fact that this Kolla community has done a great job of actually delivering a whole lot of different OCI images and help stood up a lot of different clouds that are based on Kolla and different releases, and they do a lot of work that's actually gone there to actually help deliver. What we want to do is make sure to help partner with the Kolla community and deliver OCI images that are fully compatible with the Kolla community, and kind of build on the shoulders of giants that have actually been there. There's a lot of environments that are out there that are running on Kolla Ansible or other Kolla Kubernetes type work and things like that. And I think that's all fantastic. And I think that, we want to encourage people to be able to do a variety of things and explore different projects and really kind of just embrace that open source nature. But from our perspective, we really acknowledge the great work that they've done in the OCI images, and we want to stand behind that and produce OCI images as well that are the binary based images, since the Kolla images have actually kind of drifted towards the source based images and kind of like left the binary pieces in the background. There's advantages in both ways, and we think that there's a nice offering here we can actually have for our users to have a binary based option for the OpenStack containers and the OCI images. So we'll be working with the Kolla community, reaching out to the Kolla community and helping them, and I think it'll be a lot of good fun. They've said a lot of actual good groundbreaking work there, and thank them for their work, and we want to make sure that their work is an integral part of our solution as well. So okay, so now we're going to talk a little bit about the migration path. So I mentioned earlier, we don't want to leave our customers behind, right? And I think that one of the interesting things, and it's not just customers, customers and users, I should say that. Like, I know this is open source, and I say customers because we're from Canonical, but still, like, we have users, right? And one of the things that I think is really fun is that we don't want to leave any of our customers behind. We want to make sure to help users migrate to new solutions. And the nice thing about the way that we've done Charmed operators and the way operators work is back to the relations, is that you do have the migration story. So in this particular scenario, I've got a variety of services that are running here. So I've got services that are running on like the senders over here on the Kubernetes workers in this particular example, or I could run it over here on the compute. And it doesn't make a difference to the actual services that are actually running within the cloud. So I can migrate my services one at a time. I can go from running it on bare metal, as it might be today. And then as we migrate, we can migrate a single service over into the Kubernetes worker to where they're actually moving over and they're actually running on the Kubernetes substrate. And because of the power of relations that we talked about earlier, like, it's going to be able to share, how do you actually connect to me? How do you actually configure yourself based upon these the particular constraints and configuration for that particular service, and how does it expose itself out as a service to other charms and applications? So I think it's really powerful that we have the opportunity to actually run the services wherever we need to actually run them, and that provides a nice migration path for our users and our customers as we're moving forward. So now this is all, we're talking about it. We talked a little bit about Sunbeam here, but you can get it soon, right, James? Like, it's coming soon.
Yeah, real soon. Yeah.
Yeah, so keep watching this space. At the end of the month, check out microstack.run. We intend to introduce Sunbeam to the world and be able to have a launch by the end of the month so people can start playing with it and seeing what this actually looks like. We want to start with the microstack developer experience, so we can get a lot of feedback. That's one of the things that we do want to do here, is make sure to put things out to get early feedback as early as we can. We know that what we want to deliver, you help make it better. So one of the things that we want to do is put it out there so that you can help us make it better. Give us your feedback, give it a try, let us know what works for you, what you'd like to see in the product, all that type of fun stuff. So at the end of the month, microstack.run, and you'll be able to check out the MicroStack installation from the beta stream. And with that, I think that's all we had to say. Is that right, James?
I think we've covered the majority of things. There'll be an opportunity to ask questions. But in the meantime, we'll hand you back to David and see you at the booth on B28.
All right.